Okay, so we're going to run through two more chi-square examples here real quick, just so we can remember some of the symbols here. This is your symbol for chi-square. Okay, it almost looks like a fancy X. Okay, but that's your symbol for chi-square. So let's look at this problem here. A poker dealing machine is supposed to deal cards at random, as if from an infinite deck. In a test, you counted 1,600 cards and observed the following. You've got 404 spades, 420 hearts, 400 diamonds, and 376 clubs. Could it be that the suits are equally likely, or are these discrepancies too much to be random? So we're trying to see if, even though we didn't get a perfectly even distribution, okay, is it statistically close enough that it's still considered random? Or are they too skewed and they're not considered random anymore? So let's look at what we've got here. Okay, so I've got spades, hearts, diamonds, and clubs. So the first thing we need here is we need an O value, right? We need, what did we observe? Well, it's given to us. We observed 404 spades, 420 hearts, 400 diamonds, 376 clubs. Our next one then is, what did we expect to see? Well, I counted 1,600 cards. I have 4 different suits. So if these are distributed evenly, right, I should have 1,600 divided by 4, so I should have 400 of each one if they're distributed randomly. So I expect to see 400 spades, 400 hearts, 400 diamonds, 400 clubs. Okay, the next step then is, let's subtract those. So when I subtract those from one another, I get 4, 20, 0, and negative 24. Observed minus expected. Then, remember, I take my observe minus expected, and I square it. And this is a formula that you're going to see on your formula chart. We're just going piece by piece here so that we can really get a feel of how to do it, and so that we don't miss any steps. Okay, so when I square these, I've got 16, 400, 0, and 576. Okay, when I squared my observe minus expected. And then my final step, right, is my observe minus expected squared, so that number I just figured out, divided by my expected. So when I take 16, okay, I take my observe minus expected squared, and I divide that by my expected, okay, then I am going to get 0.04. Okay, when I do the same for the hearts, when I take 400 here, and I divide that by 400, I get 1. Okay, I get 0 for my diamonds, and I get 1.44 for my clubs. And if you remember, our chi-square value is equal to, okay, so chi-square is equal to the sum, remember that symbol means sum, of our observed minus expected squared, okay, over our expected. Okay, and just in case we forget, that is sum. So I need to add all these up. So when I take this final column here and I add them up, I get my chi-square value, which is going to be equal to 2.48. Okay, great. I have a chi-square value. Well, now I need to do something with it. So let's take a look at our critical value table and see what we can do with this. Okay, so this is our chi-square, our critical value table. So remember, our chi-square in this particular problem was equal to 2.48. Okay, remember, this is my critical value here. This is my important p-value, the 0.05. That's what it's in biology, 5%. So I'm looking for where 2.48 fits on this. Well, I need my degrees of freedom first. Okay, remember, degrees of freedom were basically my variables or my samples minus 1. Well, I had 4 because I had 4 different suits, spades, hearts, clubs, diamonds. Okay, and so I subtract 1 from that and I get 3. So I'm in this row right here. I'm in the third row because that's my degrees of freedom. So I want to see where 2.48 falls on that scale here. Well, 2.48 here falls right in between there. Okay, well, my critical value is 7.81. So in this instance, with 3 degrees of freedom, my critical value is 7.81. Well, my chi-square value, my 2.48, is less than my critical value of 7.81. So in this case then, I would say that they are random. I'm going to accept it. If my chi-square value is lower than my critical value, I'm going to accept my hypothesis. And my hypothesis here is that the card suits are random. So in this case, because my chi-square value is less than my critical value, I accept my hypothesis. In this case, my hypothesis is that the card suits are going to be random. So in this case, what this tells me is that I accept that hypothesis, that the card suits are distributed randomly, and anything that is not getting 400 is due to chance. That is not statistically significant. Let's look at one more. Okay, so I've got a genetics engineer was attempting to cross a tiger and a cheetah. She predicted a phenotypic outcome of the traits she was observing to be in the following ratio: 4 stripes only, 3 spots only, 9 both stripes and spots. When the cross was performed and she counted the individuals, she found 50 with stripes only, 41 with spots only, and 85 with both. According to the chi-square test, did she get the predicted outcome? Okay, well, let's look at that. So I've got things that are going to be striped, things that are going to be organisms that will be spotted, and organisms that will be both. Okay. And I know it may seem tedious to set this up every single time, but again, it also ensures that you don't miss steps. So my observed here is that she saw 50 of them with stripes, 41 with spots, and 85 with both. Okay. I do need to know my total here. That's going to be important. How many of these organisms did she actually end up with? She ended up with 176. Okay, so now I need to know my expected. Well, I expected to see 4 stripes, 3 spots, and 9 both. That's what I expected, which that is a total of 16 organisms. Well, she ended up breeding 176. So what I need to figure out is my percentages here, right? If I have 4 that are going to be striped out of 16, right? I have 4 out of 16. I have 0.25 or 25%, right? Same with spotted. Here, let's make this stand out a little bit, okay? So then I have spotted, right? I have 3 out of 16 would be spotted, which would be 18.75% or 0.1875. And I'm not converting this to percent because then I just have to convert it right back. Okay, again here, 9 out of 16, okay, is my frequency is 0.625 of them. Should have been both. Okay, well now if I apply this to my 176 total, I can get my expected. I expected 25% of them to be striped, right? I expected 25% of them to be striped. 25% of 176 would be 176 times 0.25. So I expected 44 of them to have stripes, to be 176 times 0.25. I expected 18.75% of them to be spotted. Well, 18.75% of 41 is about 8. I expected 56.25% of them to have both stripes and spots, which would be about 99 of the 176. If you're having trouble with things like that, the percentage frequency stuff, you need to come in for tutoring. So our next one then is my observed minus expected. So I've got 6. I'm sorry, I totally wrote down the wrong number here. I am making stuff up. I got ahead of myself. 33 of them. If I had 18.75%, that'd be 33 out of 176. I had written down your difference there. Sorry. So your difference between the two is 8. Okay, and my observed minus expected of both of them is negative 14. All right, I take that now and I square it. Okay, and so I get 36, 64, and 196. And then I'm going to take that and I'm going to divide that number by my expected, right? So 36 divided by 44 is going to be 0.81. 1.94, 64 divided by 33, and then 196 divided by 99 is going to be 1.98. So I have 1.94 and 1.98. Remember, my chi-square is the sum of all these. That's my chi-square. So when I sum all these up, I get about 4.73. So that's my chi-square value. So let's apply that again real quick. So in this case, my degrees of freedom, I had 3 possible phenotypes, right? I had stripes, I had both, I had spotted. So I had 3 possible phenotypes. Subtract that from 1, subtract 1 from that, and I get 2. So now I'm in the second row here. And again, my chi-square value for this, remember, was 4.73. So 4.73 falls right in here. Okay, so 4.73 falls right in this area. Remember, my critical value is when p equals 0.05. So in this case, my critical value is 5.99. Okay, well, my chi-square value is less than my critical value, so I accept her hypothesis of that particular ratio, and that anything found that does not perfectly fit that ratio is due to chance, and there's no significant statistical deviation from that. Okay, so hopefully that helps some with your chi-square stuff.